Hi, this is a meeting about the discriminant, and it is a useful tool that we use in algebra that can tell us before we solve a quadratic equation how many solutions it will have and what the type of solutions it will have. So the discriminant is the value of the number you get when you plug in A, B, and C from the standard form of a quadratic equation, the numbers for B, for A, and for C, and you take b squared minus 4ac and you get a number, okay? And we can see where that comes from when we go back to our lesson on the quadratic formula. B squared minus 4ac is this value that we found it's in the quadratic formula. It's not the square root of b squared minus 4ac, but it's the actual just value of b squared minus 4ac. In the other video we did on quadratic formula, we found that the value of b squared minus 4ac after we plugged in the a, b, and c and simplified was 40. And that told us, and you'll learn later, that told us because it's positive that this quadratic equation is going to have two answers, two real roots. So 1 plus root 10 over 3, 1 minus root 10 over 3. So let's learn a little bit about the discriminant, which is just the value of that number that's going to show up under the radical, where we can tell ahead of time before solving the equation how many roots, how many answers it will have. So when we talk about solutions and we use the word solutions for a quadratic equation, we can also call those roots. That's synonymous. It means the same thing. Solutions, roots, we can call it zeros, or on the graph, physically, what it looks like is x-intercepts of where the graph of a quadratic equation, which is a parabola, crosses the x-axis. So what happens is, if the value of b squared minus 4ac is a positive number when you simplify it, it means that you have two real roots. It means that you have two x-intercepts. You have a parabola that crosses in two places, and those are real numbers on the x-axis. So we call that two real solutions or two real roots. And so that's one scenario. Another scenario is that the value of b squared minus 4ac is negative. We end up with something that's negative. Now, if you took a negative number under the radical, well, let's look like what would happen. In this case, 5 plus or minus the square root of 9, would you agree that b squared minus 4ac, this value, if it's 9, that's a positive number? And this has a real square root, so we would say this is 5 plus or minus 3. So I would have two answers, 5 plus 3, which is 8, and 5 minus 3, which is 2. Okay, so I'd have two solutions. And that's why we would have, that shows that we would have two x-intercepts. But if the value of this number is negative, at least as far as what we study in Algebra 1, you can't take the square root of a negative number. There's no two numbers you can multiply together when you multiply it by itself and come up with a negative, because a negative times a negative is a positive, as is a positive times a positive. So when we get to Algebra 2, you'll learn how to deal with this. They're called imaginary roots. But for now, if the value of that number, which is b squared minus 4ac under the radical, is negative, it means you have no x-intercepts, okay? If this is negative, it means it's a kind of parabola that either floats above or maybe it sinks below the x-axis and never touches it, never crosses it. So that's no real solutions, no real numbers, no x-intercepts. What we do have, and we'll learn in Algebra 2, is called two imaginary solutions. Okay, so in this case, you would just be done and you'd say, I can't take the square root of a negative value, so no real solutions, if you were simplifying the quadratic formula with that. The third scenario is that what if the value of b squared minus 4ac is not positive or negative, but it's 0? Okay, if the value of b squared minus 4ac is 0, well, look at what happens. What's the square root of 0? It's 0. So this is 5 plus or minus 0. So don't 5 plus 0 and 5 minus 0 both have the same value? They are both just 5. So that's a more rare case, but that's when you get exactly one point where the parabola, where the graph crosses the x-axis, and it is actually at the vertex being on the x-axis at that single point. Okay, and that means you only have one solution, because plus or minus the square root of 0 just gives you one value. So that is one real solution. Okay, so what we're going to do, and you'll come across this, is if I give you 3 exercises where you had to find the value of the discriminant, b squared minus 4ac, without solving the equation, just find the value of that number and tell how many solutions you're going to have. So in this case, the first thing you have to do is you have to get it in standard form. So I'm going to say subtract 7a and subtract 4 from both sides. So 2a squared minus 7a minus 4 equals a 0, right? Because I subtracted both of those. So now I say, okay, so a equals positive 2, b equals negative 7, and c equals negative 4. So I'm just going to say, okay, so what is b squared minus 4ac? So b squared minus 4 times a times c. So b squared minus 4 times a times c. So I put in negative 7 for b, and for a I put in a 2, and for c I put in a negative 4. So that is 49 minus 8 times negative 4 minus negative 32. So that is a plus 32, and that has a value of 81. And so the value of the discriminant, b squared minus 44c, is 81. And that is a positive number. So that tells me that this is a scenario where b squared minus 4ac is positive. I have 2 real solutions, or 2 real roots. And in fact, you know, that would happen in an example where I did. Okay, so going to the second one, to get this in standard form, I have to add 2n to both sides. So I get it in the right form, the n squared, then the plus 2n plus 2 equals 0. So in this case, a is 3, b is 2, and c is 2. So the value of b squared minus 4ac, b squared minus 4 times a times c. So b is 2 times 4, a is 3, and c is 2. So this is 4 minus 12 times 2, 4 minus 24. So the value of the discriminant in this case is negative 20. Okay, here it was 81. Here it's negative 20. It's negative. That means no real solutions, right? This is 2 real solutions. This is no real solutions. This is where I get the 2 imaginary scenarios. So when b squared minus 4ac has a negative value, we have no solutions, no x-intercepts. Okay, the last one is 2n squared plus 8n plus 8 equals 0. It's already in standard form. So a is 2, b is 8, and c is 8. So b squared minus 4 times ac. So b is squared minus 4 times a times c. So b is 8, a is 2, and c is 8. So that is 64 minus 4 times 2 is 8 times 8 is 64. 64 minus 64 is 0. Okay, when the value of b squared minus 4ac is 0, that's that situation where the vertex is on the x-axis itself, and it represents one real solution. It doesn't go low or high enough to cross in 2 places. So this is one real solution. It's like basically we call it a double root, okay, when it is a 0. Okay, so that's just a little bit about the discriminant and what it's used for, and it's something that will come in handy down the road. So anyway, I hope that helped a little, and